Hello, we are discussing about GATE 2003 ECE paper. For the circuit shown, assume that the switch is in position 1 for a long time and thrown to position 2 at t is equal to 0. Find the current I1 of t at t is equal to 0 plus. Okay. So the switch is closed at t is equal, that is switch is position 2 coming to position 2 at t is equal to 0. That means before t is equal to 0, switch is at position 1 for a long time. So over that one, the circuit reaches steady state. That is, for even t less than 0, circuit reaches steady state. Circuit reaches steady state. So just before the switch is going into position 2, circuit is in steady state condition. So at t is equal to 0 minus, circuit is in steady state, so replace inductor and capacitors with steady state conditions. Okay, under steady state, capacitor act as open circuit and inductor act as short circuit. Okay, so now the circuit is going to be looking like this. Equivalent circuit you can draw, which is position 1 is connected with capacitor, that is now it is acting as open circuit. So this is C1 is the capacitor which is acting as open circuit. Okay, and this is position 2, it is position 1. There is a resistor and capacitor C1 is connecting towards inductor, that inductor is also acting as short circuit because under steady state condition inductor act as short circuit. Next, resistor R, and it is connecting with a capacitor which is acting as open circuit C2, and this position 1 is now connecting with voltage V. So VC1, as the current flows in this direction, whenever the voltage is connected, current is flowing in this direction, so it will be positively charged, this is negatively charged. Okay, so you can also think current is flowing in this direction, this is plus minus. So VC1 and this is VC2, voltage across this one. So VC1 at 0 minus is equal to, at t is equal to 0 minus VC1. Apply KVL for this loop. Okay, so apply KVL through this loop. Because this resistor is under open circuit, no current flows through this resistor. So you are going through this voltage source and capacitor voltage and coming through the short circuit and again coming back to voltage source, that is forming the loop. So from this loop you can say this is plus minus plus minus. Okay, so V is equal to VC1, VC1 is equal to V volts, VC1 is equal to V volts. Okay, and VC2 is equal to, VC2 of 0 minus is equal to, VC2 of 0 minus is, as there is no current flows through this resistor, no voltage drop is taking place, no voltage drop is, voltage is equal to 0 which is acting as short circuit. So simply these two nodes are at this point. VC2 is the voltage from this node to this node, that is connected in parallel with short circuit. Short circuit will find 0 volts. So VC2 is equal to, VC2 at 0 minus is 0 volts. Because this capacitor is in parallel with inductor which is acting as short circuit under steady state condition, so voltage across capacitor C2 is 0 at t is equal to 0 minus. Okay, and one more condition is IL of 0 minus. Under steady state, how much current is flowing is, current cannot coming from this way, current cannot coming from this way. Okay, so IL of 0 minus we cannot calculate at this point. IL of 0 minus cannot be calculated right now. So now IL of 0 minus is 0 because no current is coming through inductor. Even though inductor is acting as short circuit, no current is coming through, so IL of 0 minus is 0. Next, at t is equal to 0 plus. Okay, at t is equal to 0 plus, capacitor has a characteristic. capacitor doesn't allow sudden changes in the voltage, so that Vc1 of 0 minus is equal to Vc1 of 0 plus, and Vc2 of 0 minus is equal to Vc2 of 0 plus. Whereas inductor has a characteristic that it doesn't allow sudden changes in the current. Sudden changes in the current is nothing but IL at 0 minus is always equal to IL at 0 plus. Okay, so inductor doesn't allow sudden changes in the current. The current at t is equal to 0 plus in the inductor is same as the current flowing through is the current which is flowing through at t is equal to 0 minus. So IL of 0 plus is equal to IL of 0 minus, which is equal to 0. Okay, which is equal to 0. And now we are going with I1. I1 is can be written as, now the circuit is replacing like this. Okay, at t is equal to 0 plus, equivalent circuit is looking like a capacitor with voltage. Okay, Vc1 is equal to V volts plus minus, and inductor doesn't allow any current, so that we are not writing inductor, because inductor now act as short circuit, open circuit, because it doesn't allow changes in the current. Okay, and now it is connecting with a resistor R and capacitor with initial voltage 0. That means Vc2 is equal to 0, which is nothing but short circuit. And now the switch is connected at position 2, not with position 1. So this is position 2 and position 1 is over here. So we are not interested in that position. So now you can apply KVL at t is equal to 0 plus. Apply KVL. Apply KVL for this one. So the current coming through this one is I1 of t. I1 of t is the current coming from this capacitor. So you can write KVL, which is minus V minus I1 of t. Same current is flowing through both the resistances. So I1 of t into 2R is equal to 0. So I1 of t is equal to minus V divided by 2R. Minus V divided by 2R, which is the current flowing through capacitor, that is I1 of t. This is I1 of t is this one. So the right answer for this question is A. Okay, thank you. Okay, now let us discuss the second part of the same question. So write the loop currents I1 of S and I2 of S for the circuit when the switch is thrown to position 2 at t is equal to 0. So you are going to write the current equations for I1 of S, I2 of S. That means you are going to write the equations for t greater than 0, not at t is equal to 0 plus. You are not writing the loop equations for t is equal to 0 plus. You are writing the loop equations after the switch is thrown to position 2. Okay, remember that one. So now the switch is connected to position 2. Switch is connected to position 2, and there are some initial voltages are going to be takes place across capacitor when it was connected at switch 1, position 1, and there is initial current flowing through inductor. That already we have discussed. Okay, and we finalized those values as Vc1 of 0 minus is equal to Vc1 of 0 plus is V volts. Initial voltage across capacitor C2 is 0. Initial current flowing through inductor is 0. So these are the things we have already defined. Now we are going to write the loop equations, and this is loop 1 and it is loop 2. I2 of t, as the direction says, it is going through in this way. I1 and I2 flows in opposite directions. Okay, so first let us write KVL for loop 1. KVL for loop 1. First we will the time domain equation, later we will take the Laplace transform, so that you can able to apply the initial conditions. Okay, so first in this R only I1 of t flows. So in this capacitor and in this resistor current flowing is I1, whereas in inductor current flowing is I1 and I2, but both are flowing in opposite direction. So effective current is I1 minus I2 if you are referring for loop 1. If you are referring to loop 2, effective current is I2 minus I1. Okay, because reference current for the loop 2 is I2. Now KVL for loop 1. R times of I1 of t plus 1 by c integral 0 to t I1 of t dt plus L into d by dt of I1 minus I2 of t, because effective current through the inductor, both the currents are flowing in opposite directions, that is equal to 0. Okay. Now take Laplace transform on both sides. So this is R into I of s plus, okay, 1 by sc times of I of s plus initial voltage across the capacitor, which is Vc1 of 0 divided by s plus, okay, L into s times of I1 of s minus I2 of s, s times of I1 of s minus I2 of s minus, okay, current flowing through inductor, that is nothing but IL of 0 plus 0 plus, so that is equal to 0. Now you can get the equations. This is R into 1 by s, R into I times of s plus 1 by sc times of I of s plus V by s. Okay, Vc1 of 0 plus is V by s plus SL times of I1 of s minus SL times of I2 of s is equal to 0, because IL of 0 plus is 0 and this value is V. So you are substituting those values. Okay, this is R I1 of s, I1 of s. Next, this I1 of s, if you are taking common I1 of s, then it will be R plus SL plus 1 by SC minus I2 times of SL. Okay, otherwise you can write plus minus SL is equal to minus V by S. This is first equation for the loop 1. Now we will write the KVL for the loop 2. KVL for loop 2. KVL for loop 2 is I2 into R, R into I2 of t plus 1 by c integral 0 to t into I2 of t dt plus L into d by dt of I2 minus I1 of t is equal to 0. So take Laplace transform again, so that it is R into I2 of s plus 1 by sc times of I2 of s minus V2 of 0 plus divided by s plus L times of, okay, SL times of I2 of s minus I1 of s, okay, minus SL times of minus L times of I2 of 0, minus L times of I2 of, that is IL of 0 plus is equal to 0, that is initial current flowing through this inductor. So this is 0 and V2 of 0 is also 0, so you don't get these terms. Okay, now I1 of s can be written I1 of s into minus SL plus I2 of s into R plus SL plus 1 by SC is equal to 0. So using these two equations, you can write the form as, you can write this one as I1 of s, I2 of s is equal to minus V by s and 0, and this will be R plus SL plus 1 by SC, and this is minus SL, and again this is minus SL, R plus SL plus 1 by SC. This is the right equation for the KVL for those two loops. Now we will see the right option. Right option for this one will be both. This is D is the right option. D is the right option for this one. R plus SL plus 1 by SC, R plus SL plus 1 by SC, minus LS minus SLS, and minus V by S into 0. So D is the right option for this question. Thank you.